Hi everyone, Mr. G here. We're still continuing with exponents and we want to discuss law number 2. Okay, as a point of departure for this discussion, I want you to think of the following. Suppose I have 2 to the exponent 6 and I want to divide this by 2 to the exponent 4. Now, of course, if you want to show all steps, then you can punch that or use your tables of powers, figure that 2 to the exponent 6 is 64, and then figure that this one here is 16. Then again, you gotta use your calculator and you realize that the answer is 4. Alternatively, using law number 1, you can actually write 2 times 2 times 2 times 2 times 2 times 2. Okay, so it has to be 6 times over 2 times 2 times 2 times 2. Now, because there's no plus or minus sign in either the numerator or the denominator, I can divide right away. So this 2 will divide that 2 once, the same thing here, the same thing there, the same thing there, and the same thing there. Then I'm left with 2 times 2, which is 4. That's okay. That's fine. Still okay. Very correct, logical. But what if I have 2 to the exponent of 19 and I'm dividing this by 2 to the exponent of 12? Am I going to write this thing 19 times here? 2 times 2 times 2 times 2, 19 times? And write this thing 12 times so that I can see what divides and what am I left with? Well, you're probably going to get tired of that. But besides being tired, you will lose some time writing those things. And remember, I said we appreciate the lazy mathematician because he's able to come up with shortcuts which are accurate. So what I can do, I realize here that actually I had an exponent 6 there, an exponent 4, and I'm left with 4, but 4 is just 2 to the exponent 2. Wait a minute. What is the difference between 4 and 6? It is 2. Oh, okay, wait, this is weird. Is there some coincidence? Well, let's see. I did the same thing here. Let me try and change color. I did the same thing here. 1, 2, 3, 4, 5, 6. Even 1, 2, 3, 4. So I had 4 2's in the denominator. I had 6 2's in the numerator. I am left with 2 2's. Oh, okay. There seems to be a pattern here. What is the pattern? I told you 6 minus 4 is 2. 6 minus 4 is 2. So wait, am I right then to do this to say 2 to the exponent 19 divided by 2 to the exponent 12 will be 2 to the exponent of 19 minus 12, of which it will leave me with 2 to the exponent 7. Is that so? And actually can leave the answer like that. I mean, the exponent is just high. Yeah, that's how it works. You wanna try another one? Well, let's see. If I've got 3 cubed and I want to divide this by 3, and that's just 1. Instead of taking the long method, I can just say 3 to the exponent of 3 minus 1, which is 3 squared. Now this time I know 3 squared is just 9. So this law is very powerful. It's incredible, actually. So it says, in other words, let's put it in words. If I've got 2 powers that remember this whole thing is a power and that thing is a power. If I've got 2 powers and the basis of those powers are the same, I have a 3 here, I have a 3 here, then I can simply subtract the exponents. In particular, the exponent of the power in the numerator subtracts the exponent of the power in the denominator. So let's write this formally. In other words, x raised to the exponent n divided by x raised to the exponent n is the same as x to the exponent of n minus n. Need I state that if m and n are natural numbers, then we want m to be greater than n. We will look into some nice examples in the next video. But I want you to try. I like learners who try, really. I appreciate them because it is through trying that we get understanding. So I'm going to leave you with this. What is x to the exponent 7 divided by x to the exponent 2? Try that. And secondly, what about x, y? So where x is the exponent 2, y is the exponent 3, divided by y to the exponent 2. Think about it. We meet in the next video to discuss these examples. Thank you very much. Take care and enjoy.